In this video, I'll show you how to create that classic Knight Rider LED effect using Arduino. We'll go step by step through setting up the Knight Rider LED socket and diving into the code to make it all work. Whether you're just getting into Arduino or looking to add some cool LED effects, this is a fun project to try. So without further ado, let's get started. So now I'm going to go ahead and show you the socket for this project, and so I also want to explain what this project is going to be doing. And so basically it's going to have that Knight Rider effect where one LED turns on and then it shifts over to the next LED, and then the light of the LED continues to start and move down this row right here. And so one LED beyond, it turns off and turns on this LED, and this continues moving up and down the strip of LEDs. And we have this potentiometer over here, which we can move to determine how fast that LED light to be moving. And so that is basically what this project is going to be doing. And so the first LED here, LED 1, it's going to have its anode connected to digital pin 2 on the Arduino. And then the cathode side of that LED is going to be connected to a 330 ohm resistor, which is then connected to the ground rail on the breadboard. And the entire ground rail on the breadboard is connected to the G and D pin on the Arduino. And so now the next LED, LED 2, that LED, its anode, is going to be connected to digital pin 3. And it's saying the cathode is going to be connected to a 330 ohm resistor, which the other side of it is connected to the ground rail on the breadboard. Then LED 3 is going to be connected to digital pin 4, and it's also going to be connected to a 330 ohm resistor, which is then connected to the ground rail on the breadboard. And then LED 4 is going to be connected to digital pin 5. Then the anode side of LED 5 is going to be connected to digital pin 6. Then the anode side of LED 6 is going to be connected to digital pin 7. The anode side of LED 7 is going to be connected to digital pin 8. And then the anode side of LED 8 is going to be connected to digital pin 9. And so that's how you connect up all the LEDs. So now we're going to see how we connect up the potentiometer. And so as you can see, one side of the potentiometer, it doesn't matter which side it is. It could be either this side or this side. It can be connected to the ground. Okay, so we just connect to the ground rail. And the other side is going to be connected to positive 5 volts. And so as you can see, we connected to positive 5 volts here, the 5V pin on the Arduino. And so then the middle pin, it's going to be connected to the analog pin A0 on the Arduino. And so basically that is the circuit. So go ahead and connect that up, and then we'll go ahead and look at the code. Okay, so now here is our code right here, as you can see. And the first thing we do up here is we say define pot. And so basically we're just putting the number that the middle pin of the potentiometer is connected to, which is A0. So we're putting the value A0 into the variable pot, which is standing for potentiometer. And so then we do int dt. This is just going to be storing our value of how much time we need to delay it until we move the light of the LED over. And so this will be determined based on where we move that potentiometer. And so then we go into the voice setup and we do pin mode pot input. So basically this is meaning that the pin A0 is going to be an input. Okay, and so we're just saying that we're going to be reading from this pin, which we are. We're going to be reading the value from the potentiometer. And so now what we have here is we want to set up all of our digital pins that our LEDs are connected to. But the thing is it's kind of a waste of lines of code if you just define them one at a time like this. You know, you define like LED 1, and then you use no pin mode and then do LED 2. That's just a waste of time. What we do is we use a for loop if we are, defining a group of digital pins that are all going to be outputs. And so what we do is we do for int I, so just setting up the I variable, and that's going to be equal to 2. The reason why we make it equal to 2 is because the lowest pin that we are connecting an LED to is pin 2, so that it will pin 2 and we will be set up in this for loop. And so then we're going to continue looping this for loop until I is no longer less than or equal to 9, meaning that once we get to the value 9, we need to stop, because we only connected our LEDs all the way up to pin 9. We didn't go any higher than that. And so we want to stop there. And every single time we go through the void loop, we just increment the I variable. That's what we're saying here. Okay, so what happens here is that every single time we go through this for loop, the I variable is going to change. It's going to be incremented. At first, it's going to be 2. So it's going to come in through here. It's going to come in here and say pin mode I, which at first is going to be equal to 2. So we're basically saying pin 2 is an output. And then we go through the for loop again, and we increment the I variable, and now it is equal to 3. And then we go ahead and set up digital pin 3, which is connected to LE2. and it's going to continue incrementing this number all the way up to 9, so that all of the digital pins that from 2 to 9 are set up as outputs, which is what we want. And so that's basically what that is. And so now we'll go into the void loop, and what we have here is a for loop, and what we do here is say int I equals to 2. So we're going to start at the value 2, which we're going to be starting at pin 2. Okay, so that's going to be the first LED that turns on, pin 2, which is LED 1. And then we're going to say we're going to continue looping this for loop until I is no longer less than or equal to 9. Because the only pins that we want to use with this Knight Rider is pin 2 all the way to pin 9. Those are all of the digital pins we want to use. Okay, so if I goes over that, then we want to stop the for loop. And every single time we loop the for loop, we increment I by 1. And so then the first thing we do is we set up a DT. So DT is equal to analog read pot, which means A0. So basically, we are basically reading A0, so we're getting the value from that potentiometer, the middle pin of that potentiometer, and we're putting that value into the DT variable. So then what we'll go ahead and do is we do digital write, meaning that we're writing from the digital pin, and we do I. So that means every single time we go through this for loop, the number is going to be different. It's going to be constantly rising until we reach to the other side of the LED strip. And so this is going to be different every single time. It's going to be increasing. So we're going to be going to one LED, and then we're going to move over to the next, and then we're going to the next, because the I variable is incrementing. And we say it's going to be high. Okay, and then we do delay DT. We wait for a certain amount of time until we move over to the next LED, or before we do the next loop. But right here, as you can see, we have another for loop in here, and this is just going to go through all of the digital pins and turn them off. Okay, so as you can see, we just start at digital pin 2, and we go all the way up to digital pin 9, and we just turn them all low or off. And so it's going to do this really, really quickly that you're not going to be able to see that it turns all the LEDs off. The reason why we're doing this is because we don't want LEDs to slowly all turn on. We want one to turn on and then the other one turn off while the other one turns on, and just moves over slowly, okay? And so that's basically what we do there. We turn off all the LEDs, and then we come through this again, and then we'll turn on the next LED that's next to turn on. And we're going to do this really, really quickly that you can't see that all the LEDs turned off. You'll be only able to see that the LEDs that were on have been turned off. And so basically that's what that is. And so it's just going to be moving one direction. Once we hit one side, once we finally go to the other side, then we want to go back. And so then this is what this for loop is going to do. It's going to start moving back to the other side. And so we have for int I equals to 9. So basically we want to start at pin 9 because we shifted all the way over to pin 9. So we want to start shifting back to pin 2. And every single time we go through this for loop, we're just going to decrease the I variable. And so again, we read pin A0, and then we turn on the LED that's supposed to be lit up, and then we wait some time until the light shifts over to the next LED. And so then again, we just turn off all of the LEDs, and then we just continue looping. Once it hits to the other side, which is pin 2, then the whole loop is going to start all over, and it's just going to run this full loop again, and it's going to continue to go back and forth, and you'll be able to change its speed with the potentiometer. And so let's now upload the code and look at our project. Okay, so now here's the project, and as you can see, we have the LED right here, light LED shifting over. And so now what I can do is I can go ahead and start moving this potentiometer, and we'll start speeding up. So as I start moving it, I see the LED starts speeding up. The light of the LED starts speeding up. And it gets so quick that eventually you can't even see that it's turning on and off really quickly. So all the LEDs just seem kind of dim, but it's actually turning on and off really, really quickly. That it just seems like they're just really on. All the LEDs are really dim. But as you can see, if I start turning up, we can start slowing it down slowly. And so yeah. And so yeah, that is basically the project. And so there you go. Now you know how to make a Knight Rider LED strip with Arduino. And so if you like this video, consider giving this video a like. Also comment down below if you have any questions, and consider subscribing to the channel if you want to see more videos like this. Thank you all. Have a great day. Bye.